So today we will do first work energy theorem. Last time I explained you that kinetic energy of a body is half multiplied by mass multiplied by square of its velocity. So now in case a body is moving with initial velocity u, then its initial kinetic energy is half m u square. Now in case I apply certain force or I am doing some work in the body. So when I am doing certain work in the body, its velocity will increase. Let its velocity become v after application of force or after doing work w. So as the velocity of the body has become v, its kinetic energy will become half mv square. Before I applied the force, my body was moving with velocity u, so its kinetic energy was half mu square. So this is the increase in kinetic energy of the body. So work energy theorem says the increase in kinetic energy of the body is the work that I have done w. So this I would now will prove that work done on the body is equal to increase in its kinetic energy. So this is work energy theorem. So body had a mass of m. So this is the mass m of the body. This is the initial velocity. I applied a force F, and due to this force F, the body had gained an acceleration a, and a would be given by F is equal to m into a. Now in this case, acceleration a is in the same direction in which u. So a would be positive. So this is the force equal to m into a, and when the velocity of the body increased from u to v, it moved a distance s. So this is the displacement of the body for when its velocity increased from u to v. Now again we will use third equation of motion, v square is u square plus 2s. This will give me s is equal to v square minus u square upon 2a. So this is the displacement, this is the force. Work done is F into s. So work done is F. So if I substitute the value of F as m into a and value of s as v square minus u square upon 2a, now a will get cancelled, I will get half m, open the bracket, you will get this. Thus work done is equal to final kinetic energy minus initial kinetic energy, means increase in kinetic energy. So this is the work energy theorem. You should know how to prove it, and its statement also would be used in various examples. Okay. Now I will give you certain examples of how potential energy gets converted to kinetic energy. Whenever potential energy is released, it gets converted to kinetic energy. Like for simple example, stone is dropped from height h. So what is the potential energy of a stone at height h? mgh. Isn't it? Potential energy of the stone is mgh, and when it will drop down, its potential energy will become 0. So what is the work done? Whatever potential energy it has lost, mgh. So it will have kinetic energy equal to mgh. So at the bottom, when it drops, it is having high velocity, which that is kinetic energy. Is it all right? Then second example, suppose you are having a spring in a wristwatch. So when you wind the spring, you are adding elastic potential energy. The spring will release that energy very gradually and the watch rotates. In bow and arrow, the similar thing is there. When you release your hand, the potential energy of the arrow will get converted to its kinetic energy and it will go ahead with high speed. Similarly, a compressed spring is also having potential energy. When you release it, it will get converted into kinetic energy. No, we have learned about mechanical energy, but we have got other forms of energy also. Okay, we have studied mechanical energy. We have also other form called solar energy. Solar energy is the energy due to solar energy is energy from the sun. Energy released from the sun is called solar energy. It is, we are using it but to a very small extent. Why? Because this is a diffuse energy, means the energy in an area is very small. But nowadays we are trying to make devices that will use solar energy to meet our energy requirement. Because other fossil fuels, you know, by burning fossil fuel, we are causing pollution, and fossil fuels are availability is also limited. Now, three important uses of solar energy. One is natural source, you know, is photosynthesis. It is used by plants to convert solar energy into chemical energy, because it is by solar energy you are occurring photosynthesis, which produces fruits, plants, leaves, all those things. Then we have got solar panel. Solar panel means any surface we are making it black so that it will absorb the energy, it will become hot, and then some water is passed through that surface, like you have taken a pipe. Suppose you are taking a pipe, you are making this pipe black from outside. Here this is a black surface, and here you are passing water. So this water will get heated up. Or even for simple examples, in previous, since ancient times we are using for drying our things. Then we have got solar furnace. So as the word furnace is there, means we are heating to a very high temperature. That is possible because we are focusing the sun rays falling all around the furnace with our mirrors, parabolic mirror. They are focusing the sun's energy to a small area. So there the water will form steam at a high temperature, which can be used to run turbine and produce power. Then we have got solar cells, like in the calculators, everywhere we are having solar cell. So what they do, they are semiconductor materials. So on one side we allow the sun rays to pass, so it becomes at a higher temperature, and other is at a lower temperature. So due to this difference in temperature, this material produces electric current, which is called solar cell. So solar cell gets formed. Then heat energy. This was very much familiar. When we burn our fossil fuel, steam is produced. Then this steam we are using it to run the turbines, and turbine rotates the armature of a generator, so electricity is produced. So we can produce heat energy either by burning fossil fuel or gases or any liquid oil, or also nuclear fuel. But when we use nuclear fuel, we call it nuclear energy. Then light energy, like the bulbs and various things, when they become at a higher temperature, they emit light. So that is called light energy, because of which you can see, the eye becomes sensitive. Then chemical energy is energy stored in various forms, like food also has got chemical energy. So when oxidation takes place, when you eat the food, it releases the energy. Plants convert solar energy into chemical energy during photosynthesis. It's all right. So we'll try to proceed further. Electrical energy, you are familiar with electrical energy, you are using it day in and day out. Then sound energy, energy due to vibrating body. If you vibrate any body, it produces sound which are sensitive to ears. Then magnetic energy is the energy by magnet, which you know, you take an iron body near to a magnet, it attracts it. so it is lifting, so it is doing the work against gravity. So that is magnetic energy. Nuclear energy, I explained you. Whenever we are burning nuclear fuel, there are two types of reaction: nuclear fission and nuclear fusion. But for still so far, we are using only nuclear fission for peaceful purposes, for production of heat energy, and it is because mass gets converted to energy, and it is given by this relation: E is equal to mc square. So because mass is getting converted to energy, and the connection between the two is given by, relation between the two is given by E is equal to mc square. So m is the mass deficit. So if this mass gets converted to energy, you get this. C is velocity of light in air or vacuum. Then tidal energy, energy due to high and low tides. We can make use of this also and run our turbines. What we do during high tide, we have built a dam so that water goes from other side of the dam and it runs the turbine. And when it is low tide, then the water stored from on the other side of the dam is allowed to pass through and run the turbine. So in this manner, nowadays we have started using tidal energy also. Then geothermal energy. Thermal means heat. Geo means inside the earth. So certain nuclear disintegration reactions are taking place in the interior of the earth. So they release the heat energy. With this heat energy, the groundwater gets converted into hot, becomes hot, and we call it springs, hot springs. Or sometimes even it forms steam, so we drill the hole and take this steam for our useful purposes. Then wind energy. Since ancient time we are using this wind energy to pump water. Nowadays we are having wind farms. Wind farms means many windmills are located in a small area, in a like a farm, and they produce electricity, and once all are connected, so we get adequate amount of electricity produced from this wind. So in South India we have various electricity production from wind. Thank you. We'll continue next time.